So the point of today's lecture is to really talk about assemblies. The first thing we're going to start with in the software portion is we're going to talk about how do we create assemblies. We're going to create some simple assemblies and just kind of refresh your memory on how to create assemblies. You should have some idea on how to create mates, how to do concentric mates, how to do all these things. And then we're going to move on the most important piece, which is how to create a drawing. Okay, so we're going to be creating drawings for an assembly. This is very important because your entire project is going to be based on this, and we're going to have to understand how do we create a drawing for an entire assembly, including a cover sheet, and how do we support it with individual drawing pages for the parts that are included in that assembly. Okay, so everything as usual is linked. So the whole idea of an assembly drawing is to understand how do we put it together. So if you ever bought any furniture from IKEA, or you assembled anything, you always have that first page that when you open it, it's basically an exploded view with arrows pointing in each part, telling you that you have 10 of these M10 bolts, you have that many of these pins, you have 3 panels, and they're all numbered and they all have letters. So when you try to assemble it, it's very easy for you to assemble. That's what we're going to create today. We're going to create that drawing. We're going to create that document that will help us do that. If you've had your introduction to engineering, you probably had some instructions on how to create, or some experience on how to create instructions for assembling things, depending on who was your instructor. So here's an example of an assembly drawing. What you'll see in an assembly drawing is a couple of things. One, there are no dimensions. Okay, so we try not to use a lot of dimensions, and we only use them if absolutely needed. But the whole idea of an assembly drawing is to outline all the parts that we are going to be using. So you'll see that every part is numbered, and then that part is outlined in something we call a bill of materials. So when I tell you go ahead and create a BOM table, it's a bill of material table, and that will list the part name, the part number, how many do we want of them, and sometimes it actually lists the materials. Okay, so this is basically your cover sheet, and after that we'll have many sheets that come after it in order to support it. So let's go ahead and explore what's happening here on the bottom. We'll see that on the bottom over here it says sheet number 1 of 8. That means we have 8 sheets total, and this is the first sheet, which is the cover sheet. So let's look at the parts over here. We have about 9 parts, and we can see it over here. So we have 9 things. So where are these sheets coming from? So that's what we're going to have to explain over the next couple minutes. Okay. So just like I said, we usually don't try to put dimensions on there. The whole idea is just to show how those parts come together and where are those parts located in an assembly setting. Okay, so let's get to the point of actually what are those supporting documents, or what are those supporting drawings that come after that cover sheet. We have 2 types of sheets. The first one is a regular part sheet, okay, and the other one is called a standard part sheet. And the standard part sheet is something that you can pretty much buy off the shelf. It's something that you're not machining in your workshop. It's bolts, washers, anything that you can buy off the shelf that has a specific part number that you can just order directly from a manufacturer. Today we're going to be talking about different types of manufacturers. I'm going to show you one of them and how you can actually scout the web in order to find existing parts, so you don't have to design everything from scratch. So as you notice, we have the cover sheet, which is the assembly drawing, followed by each one of those parts that we need to manufacture, and the last sheet will be the standard part sheet, and you're going to see how they actually appear in a second. Okay, so let's go through it. One of the questions that I get asked is, for the assembly, do we have to create top, front, right? Sometimes you do, sometimes you don't. Remember, the whole idea of an assembly drawing is to show how this machine is coming together. So in some situation, a simple isometric view can show everything. A simple exploded view with a collapsed view next to it can show everything. So you don't really have to follow the standards of orthographic projections of top, front, right. It really depends on conveying your idea of how those parts are coming together. Okay, so you'll see here that this is a situation that by simply just having one view like we had a second ago, we're not able to point all the parts. That's why I had to do top, front, right, because that's the only way I can actually point out all these parts. In other situations, like this one, you'll see that I can actually find all the parts included in this assembly only from one view, from the front view, so I don't have to add any additional views. Does that make sense? Okay. Alright, so let's start with this. So this is an assembly. Okay, it includes 3 parts. So we have a top plate, a bottom plate, and we have a pin connecting them. And you can see where those parts are located because by simply following the part number and the balloon indicating where that part is located, I can tell pretty much where that's going. So I have 4 sheets total, and this is sheet number 1. Okay. So as I keep going through this, so this is the first sheet. This is the cover sheet. The second sheet will be. I'll come back to this in a second. Just give me a second. I'll come back to this. But I want to show you the second and the third sheet. So I'll come back to these. Don't freak out. Okay. So when we go ahead and balloon these, it's very important, just like when we had grouping in terms of dimensions, that we actually go ahead and line up our dimensions, our balloons. Okay, so we can't just have balloons everywhere like a starburst. Okay, it's very nice and it looks very clean if I have it like this. So all the balloons need to be vertically aligned or horizontally aligned. It just creates a better flow and allows you to understand the part in a better way. Okay, now sometimes even top, front, right are not good enough in order to show all the components of the parts. So we can use something that we learned last time called section views. The issue with the section view, and this is kind of, it's not going back. The issue with the section view for an assembly, it's different than a section view for a regular part. The reason for that is an assembly is composed of many parts. So instead of just going with slanted lines, just like when we did the crosshatch for a part, we actually have to follow it based on every single part. So these are 4 different parts that are connected together through an assembly, and we went ahead and created a section. That's why when we create the crosshatch, we have to start with a sequence. So we start with a 45, then by a negative 45, and then we do a 30, and then a negative 30, and then a 60, and then a negative 60, or 60, negative 60, 30, negative 30. Okay, so you kind of follow that pattern, okay, in order to make sure that when I look at this, it tells me that this is one part, this is another part, this is another part, and this is another part. So it doesn't create the confusion. This is fully one part. Okay, is that clear? All right. So another question that I get asked: do we have to include hidden lines? If you want. Okay. Again, it depends on if we'll get the message across. So it's kind of a very vague line, and it totally depends on the assembly that I'm going to give you and the assembly that you end up designing. So in most situations, we try to avoid hidden lines in an assembly setting because it just makes it too cluttered. But if you have a simple assembly and you feel that the hidden lines are going to help you understand how you put those parts together, then you go ahead and put hidden lines. Okay? The exercise that we're going to go over in a second is not going to include hidden lines. Alright. So do we include hidden lines? Sometimes. It totally depends, just like what I said. Alright. Now, so do we include dimensions? No. Now, the only time you include dimensions is, let's say you have 2 plates, right? Actuator plates that you need them at a specific distance no matter what. Now, perfectly speaking, they're not going to be at this distance unless you have a part holding them at that distance. So if your machine has vibrations or anything like that, and those parts are going to end up moving, they're not magically going to stay in space in a place and keep that distance in between them. So you have to put some part there, and that's where the distance comes in play. Okay, so the size of that part will specify the distance. But if you want to specify that this is so crucial that the distance between those 2 plates is 5 inches, then you go ahead and do that. Okay. Alright, so those balloons, just like their name, they're called ballooning, and it's the idea of numbering each part and linking that number to a row in the BOM table. Alright, so before we said that leader line should always be pointing up and so on, this is different than the leader line of a dimension. Okay, so in this situation, the only thing that I want you to remember is please try to keep your balloons either horizontally aligned or vertically aligned, and do not cross them with each other. Okay, so the same laws that we learned before when we learned dimensioning kind of still applies here. Okay, so here's a BOM table, and there are 2 ways that we can actually represent a BOM. Notice that the numbering here goes from 1 to 13 as we go down. That's one way of representing it. Another way of representing it is from 1 to 13 going up. And we're going to see those 2 variations when we get to SolidWorks. Okay, so that's the first one. Okay, and this is the second one. See the difference? Okay, so if we go 1 and increasing number, then the table has to be located in the top right corner. If we go from 1 and up increasing number, then it has to be located in the bottom right corner. Okay? Okay, so let's go through an exercise here. Now, we talked about standard parts. Now, those are parts that you can just buy off the shelf, that you're not manufacturing on your own, and that they have a specific quantity that you can just get. So, for example, compression spring. My company does not manufacture compression spring. I'm going to buy that compression spring. It has a specific inner diameter. It has a length. So notice that the way that I list them is different than regular drawing. So in regular drawing, for example, if I would have manufactured this compression spring, I would have had to do the top, front, right, put full dimensions on them, put center lines, put hidden lines, go through all that. But considering this part is something that I'm going to buy off the shelf, all I have to do is just specify the requirements in terms of materials, the quantity, and the size, and then I'm good to go. Now, what I usually like to do is, if I know my manufacturer, if I know that I'm buying this compressed spring from McMaster or whoever the manufacturer is, all I have to do is I usually actually type the name of the manufacturer here and include the part number. Now, by doing that, that does not eliminate the need to put all these numbers, because what happens if that manufacturer goes out of business or ends up merging with another company? Then you're not going to be able to reference that part number anymore, right? Their website goes down, whatever it is. That's why you need those numbers, so you can actually go for another manufacturer and say, okay, this one went out of business, I can still get my parts in case I want to manufacture this later on. Okay, is that clear? Questions? Okay. So these are the information that we talked about. Alright, so let's say this is the example. This is an assembly. So we're going to go ahead and create a drawing package for this assembly. So the first sheet would look something like this. Okay, and I decided to go with 2 views. I'm going to go ahead and balloon it. And we're going to do all this in Solidworks in a second, but I'm just going to go through it so you can understand the concept. So if I go through all this and I go ahead and balloon it, you'll see that I have 4 parts. So I have a pin here, I have a snap ring, I have this L shape, and I have the cantilever. So after I balloon it, I'm going to go ahead and fill my bomb table. So I get something like this. Okay, and then I'm going to go ahead and fill the details here on the bottom. So I get this. Now notice that the number of sheets says 5, and you're going to see why in a second. Okay, so as you'll notice that we have the cover sheet and we have 4 additional parts. So total sheets 5. Okay, but one of them, if you notice here, the snap ring that I needed 2 of them, I do not have the material here. That means this snap ring is something I'm going to buy off the shelf. So I'm going to show you how we're going to display that as a standard sheet, but it's still going to take up a sheet. Okay. Now, if you have like 5 of those of the same, 5 different standard parts, then the number of sheets will probably still be 5, because you can fit a lot more parts that are standard on one sheet. So it's not 1 part per sheet, unlike a regular drawing. Okay. So we go to the second sheet that we just go ahead and dimension it. This is what we've been doing all semester. Okay, so this is the first part. Okay, I go ahead and dimension it. Full dimensioning, top, front, right. I put everything in here. I go ahead and fill in my information, and this is number sheet 2 out of 5, and I get this. Okay, I get to the second part. So my second part is something like this. I go ahead and dimension it again, and I go ahead and fill the information on the bottom. And this is sheet 3 of 5. You get it? So everything that we've been working up to, the dimensioning, the drawings of individual parts, now they're the part of that package, right? Because every part is that part of that assembly. Okay, so they're part of that package. Okay, this is the pin. So I go ahead and create the orthographic views for that, and fill it on the bottom, and that's 4 out of 5. And the last one is basically a standard part, so all it needs is a balloon, and it tells me what it is, the specification of it, and I don't have any part number here, but I'm going to show you how you can actually pull that part number in a second. Does that make sense? Is that clear? Okay, good. So what am I talking about? What are those websites that we can use in order to get those standard parts? Well, let's start by taking a look at my favorite, and the one that you're going to be using the most is McMaster. So if you just go to McMaster, it's pretty much an entire library of stuff that you need for anything. Okay, anything you can think about, ladders, whatever it is. But the majority of the time that you're going to be using this is mainly for nuts, washers, bolts, things like that. Things that you really don't want to design. Okay, you want to make sure that your entire assembly, has a counterbore size for a bolt that's already on the shelf. You don't want to be designing your own bolts, doing your own stress testing on bolts. You want to get something off the shelf and dimension your holes accordingly. Okay, so that's kind of where the sizing and picking up numbers makes sense. So for example, let's say I'm going to go with, you can even do bearings. You can do whatever you want. They have a lot of stuff, trust me. And there's actuators and everything like that. And the cool piece is you're going to see in a second. So let's say I'm going to get a bolt. So I click on bolts. Okay, what kind of bolts do you want? Let's say I want a socket cap screw. Okay, so I click on that. And then it gives me just options and options of possibilities, right? All I have to do is, in order to decrease those options from the properties over here, what I can choose is if I want a socket head, so I can click on socket head, and everything that you choose starts kind of becoming like an additional filter. Okay, so I want a socket head, I want a thread size of 264, right? And this gives me the possibilities based on my selection. Okay, so only these options are available that has a socket head, and it's in inches, and it's 264. Okay, so depending on what you want, you can go ahead and choose that. For example, you can even choose materials. So hey, I want steel, I want different types of drive, I want the pitch to be this. So you can choose all that stuff and specify it depending on what you really need. Now here's the cool piece. When you get here, you actually can see the part number, and this is the part number that I was talking about. So this is the part number that you can actually include on your drawing if you want to make it easier for the person who's ordering this. Now it's not only this, you can actually buy this. So this is a shopping website. Let's say you really need these bolts. All you have to do is just click on them, and you say how many do you need, and you can go ahead and add it to your order. And you put your credit card information, and they ship it to you. Okay, so it's an actual website that you can use and you can get materials from. Now the cool piece that you're gonna love is over here. There's an option called CAD. Okay, now this option is not available for everything on the site, but it's available for about a pretty hefty 70% of the options on the site. So if I go ahead and click on CAD, okay, look at this. Now not only does it give me a drawing, it actually gives me the option to download a Solidworks file. Okay, so I don't show you this in previous classes, but welcome to heaven. Alright, now all you have to do is just click save, and all I have to do is just click on it, and magically you just created. That's why I don't care about creating threads or anything like that. There you go. Okay, now why is this nice? Not only did I just save myself about 3 hours to do this, okay, but I actually use this to learn. Because if you notice from here, from the side, I can actually take a look at the sequence of things that they've done, and I'd be like, oh, that's how you do things. Okay, so I can use it to learn to learn how do you do threads, how do you do something like this, how do you, you can go through these processes of just learning by reverse engineering. Does that make sense? But this would have taken you at least an hour to do. Okay, to specify your pitch and to do all that stuff. And this looks nicer. No offense. Okay, I believe in you, but this looks nice. Okay, and you know exactly this is what you're going to get in the package that you're going to order. So there's not going to be any surprises of, oh, I meant to type 1.05, not 1.5. Okay, so that's kind of what you get. Okay, and they have everything: ladders, actuators, pneumatic actuators, all that stuff that you really need, and you can just bring it in and download it and use it. Okay, is life better now? Now you see the brighter side. Okay, so so that's the first comment. So the other website is called Masumi. It's a good website, but it's very metric based. Because it's a Chinese website. It's very metric based, and a lot of the things I'm going to be giving you or you're going to be designing are going to be mainly in inches. So I like McMaster. It's a very easy to use website. Assuming it's not that bad, but it takes you some time to get used to it. Okay, are we clear? Alright, so at this time, I hope that everyone has downloaded that zip file that I told you about, and you can go ahead and unzip it. So by simply right click on it and hit extract all, just go ahead and unzip it, and we're just going to go through some basic review of how to create assemblies, and then after that we're going to go into creating the ballooning and going through that process. Okay, so you should have that wheel mechanism and you should have the parts inside. Now I already gave you the assembly, so please don't open that yet. Okay, but what we're really designing, we're not going to go through all this right now in class. Okay, but it's a wheel mechanism. It's a silly wheel mechanism, but it gets the point across. Okay, so we're going to go through something like that just to remind you of how to create assemblies, but you should know how to do some of these things. I'm going to show you some additional hints that we didn't talk about before, but then we're going to open this up and go ahead and create the ballooning in a drawing setting. So for now, I'm just going to go to File, New, Assembly. So File, New, Assembly, and I want you to go ahead and import by simply clicking Browse, import the base. And I want you to import the mount, and I want you to import the wheel. So we're only going to be worried about those for now, and you can I'm pretty confident that you guys can assemble this together so you can assemble this on your own time, given that I gave you the assembly. So if you get stuck, you can always trace back the mates and go from there. Okay, does everyone have this? Okay, so a couple of things I want to point is, before we used to mate everything based on surfaces. The problem with that is if that surface would have changed, for example, if we add a notch in a surface or we change the diameter, sometimes what might happen is the mate might get broken because it will not recognize that surface anymore. Okay, so we have to remate them, we have to fix the mate, or we have to do something in order to fix that issue. Today I'm going to show you another way of actually creating mates that uses reference geometries, so you don't have to use surfaces. So no matter how much the surface changes, the reference geometry is not going to change. That's why my assembly is not going to be affected. So first things first, let's start by linking this mount to the base over here, and I'm going to do that by clicking on the bottom face of that mount and hold down the control key and click on the top face of that plate. So assemblies should be something that you're familiar with by now, but if I go ahead and click on mate on the top under the assembly tab, notice that some of the options that I have are coincident, parallel, perpendicular. Remember, try not to click on lock. Okay, so we're just going to make them coincident to each other. Basically, they're going to be directly on each other. If you remember, mate alignment can actually control, because both of these situations are possible scenarios where those two surfaces could be coincident to each other. But by using these two, I can actually line them up in the orientation that I need. So I go ahead and click on check mark twice. Now notice that it is on that surface directly, but I can still move it front and back, left and right. So now is a good idea to add some distance mates. Okay, some distance relations. So I can do that by clicking on this face, hold down the control key and click on this face. So by clicking on those two faces, I can click on mate. Now Solidworks by default will try to make them coincident, but I don't want them coincident. I actually want a distance in between. So if I go ahead and click on the ruler icon under lock, okay, it should be grayed out, but if you click on the ruler icon, it should get ungrayed, and I'm going to go ahead and type 35 millimeters, so 35 mm, and that will be the distance between the right face of the plate and the right face of the mount. Okay, does everyone have this? Go ahead and click on check mark twice because I want to show you something. Remember, all the mates that you add are actually saved in the mates window over here. So if I click on the plus from the design feature tree under mates, I can see all the mates that I already added. So if you add any mates that you don't need, or that you made a mistake, please make sure that you delete them, because just like any relation or any dimension, a mate can overdefine your assembly and it can turn it yellow or red. Now notice I can still move this front and back, so I need to add another mate to another distance mate. I'm going to add a mate between the back face of that mount and the back face of the plate. Okay, and I'm going to click mate. Solidworks again will assume that I want those to be coincident until I click on the ruler icon under lock. And I'm going to go ahead and specify that distance to also be 35. Okay, so 35 mm, I'm still using millimeters. And go ahead and click on check mark. Okay, is that clear? Any questions? So now if I grab that mount, notice that I cannot move it. If I take a look at my design tree, you'll see that there's an F in front of base. F stands for fixed. That means the plate is fixed and we're building everything based on that base. Is that clear? Okay, are we good? Alright, so here's a cool piece, guys. Before, if I want this wheel to go in here, I would have clicked here on the surface of the wheel, hold down the control key and click on the inside surface of that hole, right? That's what we would do before. Now this is fine, it still works, but if I end up changing the dimensions of the wheel, change the surface, add a notch, do anything like that, it will actually have the danger of breaking that mate. Now here's another possibility. If I go to view, temporary axes, so view temporary axes, you'll see that what I will see, or you will see that there are the blue lines, and those are the center lines of anywhere that we have an actual cylinder. So you see I have a center line here and I have a center line for that hole. Okay? So instead of selecting a surface and a surface, what I can do is I can select the temporary axis of the wheel, hold down the control key and select the temporary axes of that hole. So now what we're doing is we're linking reference geometries, which are axes, and those are not going to change, because whether I change the radius or whatever it is, or whether I add a notch on the outside of the surface, that axis is not going to change, right? That axis is going to be the same. So now if I click on both of them and then click mate, you'll see how they actually get lined up. Now of course this is the wrong orientation of the wheel, right? This is not the right orientation. That's very easy to fix by simply using the mate alignment options over here. So by flipping it, I can actually get my wheel to go the right direction. Okay, is that clear? Okay, now we're going to come over here and we're going to select the back side of the wheel, and we're going to make it flush with the back side of the mount, the plate, and they're going to be lined up nicely like that. Okay, any questions on that? So by clicking on check mark twice now, I can actually grab that wheel and it should be able to turn. Are we good? Is that clear? Okay, so I'm gonna close this, and magically, by blinking my eyes twice really fast, I get this. Okay? Do all of you have this? Okay, so I give you this. Just go ahead and double click on it to open it. You can close the one that you've been working on. Okay, are we good? Does everyone have this open? Don't break it, Eric. It's not a toy. Okay. Just have some music playing in the background. Alright, so we have this. It's fully assembled. You guys are having way too much fun with this, so let's focus again. It's only engineers that find this stuff entertaining, you know. All right, so we have this fully assembled. Now I'm gonna go over two things. One is how to create exploded view. We talked about that before, but I just want to make sure that everyone's on the same page in terms of exploded view. So I'm going to create one really quick here. You don't have to follow along. I just want you to take a look at the board and just watch, kind of just refresh your memory. And then we're going to take this and we're going to try to create a drawing out of it and go through that process. Okay. So in order to create an exploded view, under the Assembly tab, there's an option called Exploded View. So we're going to go ahead and click on that. Okay, I've already created an exploded view for this one. Let me take it a step back. Alright, so this is what you have. Alright, you cannot click on a part and drag it. You have to click on the part until you see the tripod, and then you hover over the arrow in the direction that you want to move in, and you grab and you drag. Okay, so we can actually go through this process of doing it for each one of those plates, and I can move them in different directions. Okay, and I can do multiples at once. For example, if I want this plate and this plate to move together, I can select both of them and I can explode them at the same time. Okay, now this is you know, not the best exploded view because I'm just showing you how to do it. But what you can also do is over here, do you see where it says auto spacing component? So what that means is you can actually specify the distance between those components. So if I grab a bunch of them and try to drag them just like I did over here, notice that it automatically adds a space in between them. Okay, and that will make my explode kind of look very nicely grouped. Okay, instead of just parts everywhere flying. Does that make sense? Is that clear? Okay, so what you guys, I already gave you an assembly that has a nice exploded view. So by simply clicking on exploded view, you should be able to see what I created for you. Okay, and everything that I created is over here explained on the side, so that should be pretty straightforward. Now if you want to bring it back together, we're going to right click and click on collapse. So right click on an empty space. Make sure that you click check mark so you can exit from the exploded view window, and then click on collapse and it will go back together. Okay, so let's get to the highlight of today, which is basically how do we create a drawing package for an assembly. Okay, let's start with this. We're going to go the same process that we did before. We're going to go to File, Make Drawing from Assembly. Instead of Make Drawing from Part, now we're going to be doing Make Drawing from Assembly. So we're going to go ahead and click on that, and that will open up the drawings window. I'm going to go ahead with ANSI Landscape just like usual, and there we go. Now it's up to you what view do you want to go with. So let's say for my purposes over here, maybe an isometric view is good enough. Okay, or maybe, you know, I created a couple of different isometric views. So it's really up to you. Let's see if an isometric view is good enough. So I'm just going to grab an isometric view and I'm going to put it somewhere here. Sometimes if the sizing is too small, you can always use the scale from the properties window, and you can use a custom scale. So if you don't want like 1/5, you can use 1/4 to make it a bit bigger, or maybe you know, maybe this is too big, 1/2, but maybe like maybe like a 1/3. See how that works? Okay, that looks good. Okay, is that clear? Are we good? So we just brought in our assembly. Now we need to balloon the components. Now you'll see that a lot of the things here, remember, you guys have your own drawing sheet. Okay, you guys can follow the instructions that I gave here in the lecture of what needs to be included in the drawing sheet. So if you don't need all this stuff, okay, just simplify this and just make it simple on here on the bottom, so it's only 2 rows. Okay, so you can have a lot more space to include additional details regarding your drawings, regarding your assemblies. Okay, so that's perfectly fine too, because you have it. We talked last time how to create your own drawing sheet format. Okay, so we're going to go from here, and under annotations, there's a tab called annotations. There's an option called auto balloon. Okay, so if I go ahead and click on auto balloon, notice that it will place these balloons for me. Now these balloons are already, some of them are aligned vertically, some of them are aligned horizontally. Okay, some of them are just everywhere. And you're going to see there's a different approach I'm going to show you in a second, but this is the fast and dirty way. But over here there's an option called balloon layout, and I can either make them all horizontal, I can make them all horizontal down, I can make them all vertical, I can make them go as a square, like just like the way they were, or I can make them go crazy like this. Okay, so maybe like the square option is the best option. Is that clear? Are we good? Now you'll see that over here I have 1, 2, 3, 4, 5, 6. Now knowing that by looking at the assembly that I have a lot more than those parts, what's happening? Why did auto balloon did not pick up some of those parts? Well, here's one option. Those plates are actually not the same plates. Okay, those are different plates. So for example, let's go back into the drawing. If I go ahead and isolate this, so if I just take a look at this piece and I isolate it, okay, so notice the pins here on the side. Okay, so all the pins here, we have 4 on each side. Okay, that's good. Now let's look at if we isolate this guy. That's different. It's 4 pins on this side and 3 pins on the other side, right? But if I look at my drawing on my folder that includes the parts, I only have one part that's called plate. So where are these coming from? Well, let me give you a brief overview of something that we're going to be working on in the future. If I open this part actually has something called configurations. If I click on this third menu over here, you'll see that I have 3 separate plates hidden under one part because they're so similar to each other. By simply double clicking here, I will change it. Double clicking here, I will change it. Okay? So I have 3 different plates that are saved under the same part. So we usually do that if we have the same family, just different configurations. Okay, does that make sense? Okay, so how do we actually detect that? How do we solve that problem so we can make the drawing detect it? That's where bombs come in play. Under the annotations tab, there's an option called tables. Okay, and the one from the bottom or third one from the top, so second one from the bottom or third from the top, is called bill of materials. You see that? So it says bill of materials and tells you select the drawings that you want to create the bill of materials for. Well, we want to create it for this entire assembly, so I go ahead and click on it, and then I come over here to the properties window. It says, do you want to do top level only? Yes. What top level only means that sometimes you might have, just like when we had with the V6, we had an assembly but it had mini assemblies inside of it. So do we want to do the mini assemblies as individual components, or do we want to call on the mini assembly as its own thing? Okay, so it's really up to you to make that decision. We want to start at increment. We're going to start at 1 and we're going to increment at 1. So everything looks fine here. Once I see that this looks good, I go ahead and click on check mark, and you can see that on my cursor there's going to be a table. You see that? Now notice what happened. The minute that this table was created, notice how the balloons changed numbers. You see that? Like, look at my numbers and look at yours if you haven't created the table. My balloons changed numbers. Okay, where's 1? Where's 2? Right? They're missing. So now I'm going to go ahead and place that table here on the top. So by simply clicking, it gets fixed. And I can resize these columns as I wish. And just resize them and move them here to the side. And there we go. The most important columns that you want is the item number, the part number, and the quantity. the description in the materials is actually specified in the part drawing itself. So if you want to delete that column called description, that's fine. If you want to change it to be something else, that's fine too. Okay, but the three main important ones that I'll be looking for is item number, part number, and quantity. Okay, is this clear? Any questions? Yes.
So when we have an assembly and we have our own parts, we save, say, a wheel and a spoke or whatever, axle. And when we put it in this, if we were to do this, would it automatically?
It will detect every single part, yes.
So I'm saying, so like whatever you name that file number, that's file.
Yes, absolutely. So the part number here, this is actually all, it's really not a part number, it's a part name, but it depends on what you save it as. So if your part name is A301, then it's really a part number. So it really depends on how you're saving things, but it's automatically linked to pull that information. Yes?
If you create a format that already has a BOM on there, could you just...
No, a BOM has to be created for every assembly. You cannot create a sheet format with a BOM, because that BOM is, remember when we created this, it told us select the part that you want. So we had to click here, so that's why I was able to extract it from that assembly itself. Okay, does that make sense? Okay guys, so let's keep going. So notice that my balloons now are not working. So what I'm going to do is I'm going to go ahead and delete those balloons. And you're going to see why in a second. So I'm going to go ahead and delete those balloons. And now I'm going to try auto balloon again. Okay, so I'm going to click on auto balloon. Click on the assembly. And then click on check mark. Do you see now how all my numbers are there? I have 1 through 8. Okay, so my biggest recommendation of today is you always create your BOM first before you do the ballooning. Okay, is that clear? Just click on them and delete them. Okay, you can move these balloons, by the way. Like if these balloons are not the direction that you want, you can move them. Okay, you can put them wherever you want, really. Okay, is that clear? Any questions on that? In case it did not, can you please stop printing? In case we did not detect some of those parts, let's say the auto balloon did not detect one of them for some reason, you can always come to balloon regular and actually try to click on it and try to put the number on it. Okay, so that's perfectly fine as well. But usually it does, so I won't worry about that. Is that clear? Any questions on that? You guys should be you should be able to understand or know how to modify this information, right? Any questions on that? Now, how do we do the sub pages? Okay, do you see here how it says sheet 1 of 1? Well, this is 8. Let's say the hinge pin, right? We have 6 of them. Let's say the hinge pin is something we're going to buy off the shelf. Okay, just for illustration purposes for now. So technically, how many total pages should we have? 9, right? Because we have 8 parts plus 1 assembly sheet makes 9 sheets total. So how do I do that, and how do I group them as one package? It's very easy. Just like Excel on the bottom, there should be like a tab with a star on it that allows me to add an additional sheet. So I click on it, and look at that, it's an additional sheet. Okay? So what do I do now? I go through the same process that we've been learning for the past however many weeks. Okay? We go to view layout, standard view. Hey, which one do you want? Browse. Let's say we're doing the base, open. Okay? I forgot to change this to third angle projection. But you know all these steps. We already talked about this. Okay? This is nothing new, nothing fancy. We already talked about all these. Okay? So we have this. We can create an isometric view. You come here, you add hidden lines, you add smart dimensions, you do all this fun stuff. Okay? You already know how to do all this. I'm not going to go through this, but the idea is, notice how now on the bottom it says sheet 1 of 2. Okay, so it automatically gets updated, so I don't have to do it manually. But the cool thing is when I save this, it's all saved as what? One file. So every assembly will take up one file only. That's the nice part. Okay, so I can add as many sheets as I want, and I keep doing this. So I have 9 sheets total, right? And the last one would be what? My standard sheet. Okay, so how do we create a standard sheet? It's very easy. You see where it says balloon over here? So if I come back to the sheet number 1, this hinge pin is balloon number 8. Okay, and remember, I brought in this base as the first one, and that's a mistake because the base is actually the 4th one. So please make sure that you follow those numbers based on the BOM. So the second sheet would be part 1, part 2, part 3, part 4, and so on. So how do I create this standard part? I go to balloon. Okay, circular. I want 2 characters. Instead of item number over here, I'm going to click on the drop down. I'm just going to select text. So item number text, and what number was it? 8. So I'm going to type 8. I'm going to come here. Do you see how my cursor has the balloon on it? I'm going to click and then hit escape. So there we go. We have the 8 balloon there. Okay, is that clear? Okay, now we're going to go to note. Do you see where it says note under annotations? We're going to go to note. We're going to come here, and we're going to type a note. So this is going to be called hinge pin. And let's say this is part number 9536598. Okay, McMaster. This has an outer diameter of 2 inches, an inner diameter, I don't know, I'm just making this up, right, of 1 inch, a length of 5 inches, whatever. Okay, I'm just making those numbers up right now. Okay, and I want quantity of, forgot how much was it, let's say 8, or I think it was 6, but you get the idea. You can type in the quantity. And there we go. You just hit check mark. And there you go. Is that clear? So you can create your own information over here. This got stuck here. Come on. Doesn't matter. It's not in your drawing. It just needs to refresh. There we go. Just click on the traffic light on the top and force it to refresh if you did the same thing. Okay, does that make sense? Is that clear? Any questions on that? So, create the assembly. From that assembly, you create a BOM. From that BOM, you do an auto balloon, and you just create the sheets after that. That should have the smart dimensioning on them, and the last sheet would be the standard part sheets. Any questions?
Yeah, actually, so the description, if you create a new sheet, it doesn't change with the part that you import. It's just the first page, or how do you link those?
Well, once you import the part, it will pick it up.
It's like when we did sheet 2,
yeah,
we imported the base. It still stayed as a sheet.
Oh, good question. No, it should be able to pick it up. Okay, so let me show you a hint here. Let's say the title is the one that you want to change. If you double click on that, there's an option here called link to property. You see that? So it says link to property. So when I click on that, I can specify what property do I want. So that property could be author, created date, file name, folder name, last save, whatever it is that you want. Okay? So when you create your sheet format, you can link it and you can create those fields based on whatever you want. Does that make sense? Okay, so you can have author there, you can do whatever. Now, author, don't do it because you guys have the student copy, so the author is really your MEID, so that will be annoying to put on there because I don't know your MEIDs. Okay? Any questions? Any other questions? Are we good? Alright, ladies and gentlemen, this is assembly drawings. Let me wrap this up.